Hello everyone, welcome back to the channel. Today we are starting with the revision course for this year UPSC exam. In this course we are going to majorly cover three topics, that is algebra, number system and arithmetic. And then permutation and combination probability, since there are only 5 videos on that, so you don't need a separate revision course for that. You can watch them at your own pace. This course is going to help you with the revision if you have already covered the exam, or if you are new, then this course is going to help you with all the formulas and also the PYQs which we are going to solve in this course. So starting with the first topic of algebra today, that is progressions. In progressions, we have comprehensively covered arithmetic progressions, geometric progressions and harmonic progressions. Today we are going to do the same but in a single video. Right? So let's start without wasting any time. What exactly is an arithmetic progression? Arithmetic progression is a series of number which increases by a common difference. What does this mean? Suppose I start with a number, say 2. Now in 2 I add 3, right? So then the next number I will get is 5. Now to get the next number I can only add 3. So what will be the next number I will get? That is 8. Again in the next number I can only add the same number. So then the next number will be 11. Again only I can add 3. The next number will be 14. And such series of such numbers is known as a arithmetic progression. This is the basic, right? So in this arithmetic progression you need to know two things. That is, what is the first term? Suppose this is a series 2, 5, 8, 11, 14. If someone asks you, is this an arithmetic progression? How will you check? Suppose I am removing this. Suppose someone asks you, is this an arithmetic progression series? How will you check? You will subtract second. First from second means 5 minus 2 is 3. This is, so the difference between two numbers is 3. These two numbers, the difference is 8 minus 5, that is 3. In these two numbers, the difference is 11 minus 8 is equal to 3, and so on. So every time you are getting the same difference, that is 3. And this is known as the common difference. So this term is clear. Whatever difference which is common in all the numbers of an arithmetic series is known as a common difference. And the next term is, what is the first term? First term is very intuitive. That means first term of the series is a first number. So that is 2. So if someone asks you in the above series what is the first term? The first term is 2. And what is the common difference? Common difference is 3. I hope this is clear, first term and common difference. Then moving on. General term of an arithmetic progression series. So every time if in a series we say what is the first term? First term is normally denoted as A. A denotes the first term of the series. Now how will you get the second term? To get the second term you need to add some D in the first term. So if we add D to the first term, you will get the second term. And what is the difference between two numbers? A plus D minus A means the difference between the gap between these two numbers is D. Now if you go to the third number, then what do you need to do? You need to add D in the second number. So A plus D plus of D, that is A plus 2D. I hope it is clear. What will be this is the third term. What will be the fourth term? Fourth term will be A plus 2D plus D, means A plus 3D. Then the next term will be A plus 4D, and so on, right? So here the first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D, and fifth term is A plus 4D. If you check, the number of D's is 1 less the number of terms. So this means that if it is a third term, then there is a 2 D's added. If there is a fourth term, then there is 1 less, 3 D's are added. If this is a fifth term, then there is only 4 D's added. Means every term, suppose someone asks you what is the 50th term, of this arithmetic series. You will say a plus how many d you will add? You will add 1 less than 50, that is 49d. So this is the 50th term of the series. I hope it is clear. So what is the nth term? Nth term of the series is denoted as an, means nth term of the series is a plus n minus 1, means 1 less than the number of terms into d. That is the nth term of the series. I am marking it as important, very important formula to know. Please note this down in your copy, and this will be help you in the revision one day before the exam, right? So a plus n minus 1 d is the nth term of the arithmetic progression, right? Moving on. Now, as I've already told you, suppose 2, 5, 8, 11, 14, so on. This we know that is an arithmetic progression series. Done? Now, someone asks you, give me sum of 100 term of this series. Give me sum of first 100 terms of this series. So what are you going to do? You can one thing you can do is 2 plus 5 plus 8 plus 11 plus 14 plus 17 and write 100 terms, then do the summation. This is one way of doing it. Obviously not the right way, but this is the one way of doing it. Or the formula for first n natural sum of first n numbers in an arithmetic progression is n by 2. Please note it down. 2a plus n minus 1 into d. N by 2, 2a plus n minus 1 into d. This is the sum of n terms of an arithmetic progression series. And how we're going to use it? We know that 2, 5, 8, 11 is a series, arithmetic progression series. First term is 2, difference is 5. We need to know the sum of 100 terms. So sum of 100 terms is n by 2, that is 100 by 2. 2 into a. 2 into a is 2 to the 4 plus n minus 1, that is 99, and d is 5. So if you calculate this part, you will get the sum of first 100 term of this arithmetic progression series. I hope this is clear. Simple formula. Again, I am not spending a lot of time in the formulas because this is a revision course. If you want to go into the depth, you can watch the video in the playlist Algebra, and you will find a full lecture on arithmetic progression there. There we have also derived how did we get to this, right? And now, this is the formula for first n terms of an AP. The second formula which we can use is, just see, Sn is n by 2, 2a. Can I write 2a as a plus a, n minus 1 into d? I have done nothing, just I have separated a and a. Now, Sn is n by 2, a is a plus, what is a plus n minus 1 into d? Is it not the nth term of the series? So the other formula for sum of n terms of the series is n by 2, first term plus nth term. That is the second formula you need to note down in the copy. So three formulas we have learnt till now. First one is nth term of the arithmetic progression series, and sum of n terms of an arithmetic progression series. There are two ways to get the answer: n by 2, 2a plus 1, 2a plus n minus 1 into d, or n by 2, a plus nth term, right? This is, I hope this is clear. Now, next part, very important, sum of first n natural numbers. Suppose 1 plus 2 plus 3 plus 4 plus 5 plus 6. So, natural numbers are the numbers which start from 1. So, a series of number which starts from 1 and increase by 1. So, 1, 2, 3, 4, 5, 6 and so on is the natural number series. I am not going into depth of it. The natural number series, you just need to know that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till infinity is the series of a natural number, right? I need to know what is the sum of first n terms, or suppose I say someone asks you 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 100. What is the sum of first 100 natural numbers? How will you get the answer? The formula for this is n by 2 n plus 1. or n into n plus 1 by 2. I hope this is clear. Simple formula. That is the fourth formula you need to know for the exam. And again, I'm putting a lot of stars because it's very important and will be useful in a lot of questions. So the sum of first n natural numbers is n plus 1 by 2. So if someone asks you what is the sum of first 100 natural numbers, your answer will be 100 n plus 1 by 2 is the sum of first n natural numbers. I hope this is clear. 4 formulas done till now. Now moving on to the next part. Now this is a question. I am going to partially solve it and leave for you to find the answer, right? So let's start. Very easy question. Find the 20th term of the series. First thing, if someone has given you the series, you first need to know if this is an arithmetic progression or harmonic progression or geometric progression or whatever. So first thing, is it an arithmetic progression series? How will you check? Difference between 4 and 7 is 3. 10 and 7 is 3. Next number 13, 3 and so on. So the difference between two numbers is constant, and that is constant or the same, and that is 3. So this is an arithmetic progression series where the first term is what? 4. The difference or the common difference between all number is 3. You can choose any two numbers and check this. The difference is C. Find the 20th number. So 20th number will be A plus n minus 1 into D. A is 4 plus n minus 1, that is 20 minus 1, 19, and D is 3. You will get the answer, 20th term of the series. I hope it is clear. Now, what is the sum of first 20 terms? Sum of first term 20 terms, two formulas you have, n by 2, 2a plus n minus 1 into D, or second is n by 2, a plus 20th term, means the last term. You can use whatever formula you want to use and you will get the same answer. And this is one of the easiest question of arithmetic progression, just the application of the formulas, right? Moving on to the next question. Now this is I would say that was easy. Now this will be the medium level question. Sum of certain number of terms of an arithmetic progression is 57. Means sum of n terms. N we don't know. So n by 2, 2a plus n minus 1 into D, or n by 2, a plus nth term is equal to 57. Whichever formula you want to use, this is given. The first term of the series is 17, and the last term of the series is 2, right? Find the number of terms and the common difference. So first thing, we know, should we not use this formula? Simple, n by 2, first term that is 7 plus second term that is 2 is equal to 57, n by 2, 19, 57, 19, 3. So there are total 6 terms in the series. N is 6, right? So n is 6. Now second thing they want to know is what is difference. A plus n minus 1 into D is 2. A is 17. N we know the 6. 6 minus 1. D we have to calculate, and 2. So here you will get the value of the common difference. Just the application of the formulas again. Choose whichever formula suits you and use that. I hope it is clear. Now moving on to the next part. What is arithmetic mean? Now we are going to learn about this, but with a question. What is it? What is they are asking? Find me one arithmetic mean between 25 and 75. So they are asking that 25 is here, 75 is here. Find me a number between them which is an arithmetic mean. What exactly is an arithmetic mean? Arithmetic mean is a number which makes this complete series an arithmetic progression. Means if they give you 25, arithmetic means let's say A, and 75, we will say that this is an AP, then only A is arithmetic mean, right? Now first thing is clear. Now tell me what is the common difference between two numbers, first two number, that is A minus 25. What is the common difference between A and 75? That is 75 minus A. I hope this is clear. Since it is an arithmetic progression series, the two things are equal. The common difference is equal. A minus 25 is equal to 75 minus A. Then A 2A is 100, A is 50. So A means 50 is the term which is the arithmetic between two numbers 25 and 75. Why? Because when we put 50 in between, it will become a arithmetic progression series. I hope this is clear how to calculate one arithmetic mean between two numbers. Now the next question, more advanced one is, there are two numbers given to you 3 and 23. Now instead of one arithmetic number, they are asking you, give me four arithmetic numbers between these, A1, A2, A3, A4. I need four arithmetic mean, not one, not two, but four arithmetic mean. Now, how to calculate all these arithmetic mean? These numbers are such that this complete series 3, A1, A2, A3, A4 and 23 is an arithmetic progression series where first term is 3, second term is A1, third term is A2, fourth term is A3, fifth term is A4 and sixth term is 23, right? Now we know first term, that is 3. We know what is the sixth term, that is 23. So can we not calculate the difference from it? Yes. So an sixth term of formula for sixth term is a plus n minus 1, that is 6 minus 1 into d. 23 is equal to a is 3 plus 5, and what is d? D. 23 minus 3, 20 is equal to 5d. You will get d as 4. So difference is 4 in this arithmetic series. I hope this is clear. Difference is 4. I am just removing it. So difference is 4. Common difference is 4. I am writing it here. Now, if first number is 3, what will be the next second number? We have already seen a plus d. A plus d means 3 plus 4. That is 7. So a1 is 7. What is the next term? Then again 3 will be added. 7 plus 3, 10. Again the next term will be 10 plus 3, 13. 13 plus 3, 16. Are we doing it right? I hope we are doing it right. 13, 3 plus 4. Sorry, I'm making a mistake here. I have to add 4. By mistake, I was adding 3. 3 plus 4, 7. 7 plus 4, 11. 11 plus 4, that is 15. 15 plus 4, 19. And 19 and last term is 23. So this complete series is now an arithmetic progression series. And these four numbers are four arithmetic mean between these two numbers. I hope this is clear. Moving on, arithmetic mean thing is also done, right? Now moving on, our arithmetic progression part is over. You just need to know those formulas which I have highlighted, and you just need to know how to calculate it arithmetic mean between two numbers. Either it could be one arithmetic mean or more than one arithmetic mean, does not matter. You know the how to do it, right? Now let's start with geometric progression, and we are going to do it by comparing it with the arithmetic progression series. So that way it will be easy for you to remember. So what is a geometric progression series? In arithmetic progression series, the next number was, how did you get the second number? By adding d from in the last number. By adding common difference in the last number, you are getting the next number. But here what is happening? Suppose first number is 2. Instead of adding, I am multiplying. So I multiply 3. So what is the next number I will get? 6. Now again I multiply 3. 6 is 18. 18 3 is 4. 54 and so on. So to get the next number, you are multiplying and not adding in the last number. So that is the difference between arithmetic progression and the geometric progression. Here what is the first term? First term is nothing, just this part, and this is again denoted as a. What is the common ratio? In that there was a common difference. Here we have common ratio, and common ratio is denoted by r. So first term is clear. First term is first term of the series, and common ratio is whatever is getting multiplied to get the next number. That is common ratio. I hope it is clear. Moving on. How to write a general term of the series? So first term of the series is always a. To get the next term, you multiply it by the last number by r. So a into r is ar. Now multiply last number again by r. ar multiply r is ar square. Next again multiplied by r, so ar cube. multiply by r, ar 4, and so on. So the first term of the series is this, second term of the series is ar, third term of the series is ar square, fourth term is ar cube, and fifth term is ar 4. Now again you will again see, whenever there is 5 here, the power of r is 4, like same as a common difference. So the nth term of the series is a r raised to power n minus 1. Note it down, a r n minus 1. There is always one power less than whatever the n value is. This part is clear, nth term of a geometric progression series. Now moving on, sum of n terms of a geometric progression series. So the formula is, I hope you know, understand what the n term of what does n term of GP means? Means suppose this is GP, 2, 2 multiply 3, 6, 6 multiply 3, 18, 18 multiply 3, 54, and so on. This is a geometric progression series. So if I need to add all these numbers and get the sum of n numbers, so the formula is sum of n numbers is a r raised to power n minus 1 upon r minus 1. This is important formula, note it down. A r raised to power n minus 1 divided by r minus 1, and that is the formula for n terms of a geometric progression series. I hope this is clear. Now, sum of infinite terms of a GP. See, this is this a, let's say, infinite term. How will you write infinite term? Suppose the series start with 2. 2 multiply to 4. 4 multiply 4 multiply to 8. 8 multiply to 16. 16 multiply to 32. 32 64. 128. 256, and so on. If you add all these numbers till infinity, you will get answer as infinity, because you are just adding, the sum is getting bigger and bigger and bigger. So in this case, the sum is not possible to be found. Only in sum of infinite terms, we can only calculate when the common ratio value is less than 1 or greater than minus 1. How, we will see. Now I hope this is the thing you need to note down. You can only calculate the sum of infinite terms of an arithmetic geometric progression series if the common ratio is between 1 and minus 1. Now suppose the first term is 1, second term is 1 by 2, third term is 1 by 4, fourth term is 1 by 8, fifth term is 1 by 16, and so on. So if you add all these numbers, you can get the sum of it. Why? Because the common ratio here is 1 by 2, which is between this range minus 1 and 1. So we can calculate the sum of infinite terms of such geometric progression. So here in this example, the sum of infinite terms, the formula is a upon 1 minus r. Please note it down, a upon 1 minus r, but the only condition is that the ratio has to be between 1 and minus 1, right? So here in our example, what will we get? In this example, the sum of infinite term of the series, sum of infinite term of series is 1, that is a upon 1 minus 1 by 2, right? 1 upon 1 minus 1 by 2. So if I calculate this, what will I get? I will get 1 upon 1 by 2, 2. So this term, this series, if you sum till infinite, you will get answer as 2. So the sum of infinite terms of the GP is possible using this formula, given the condition that the common ratio is between 1 and minus 1. That is all. Moving on. This question is homework for you, simple question. The first term of the series is 10. The common ratio is 3. Give me first 5 terms. This is 1, 2, 3, 4, 5. I will give you the first term, that is 10. Second term, multiply last term by 3, or that common ratio 30. Next term is 390, and so on. And this is how you calculate the terms of a geometric progression series. Now this is a geometric progression series given to you: 10, 30, 90, 270, 810. Now first thing, tell me, is it a geometric progression series or not? Answer is, how will you see? This number we have got by multiplying the last number by 3. This number we have got by multiplying last number by 3. 3, 3. So the common ratio between all these numbers is 3. What is the first term of the series? That is 10. So the sum of first, how many terms are there? 5 is a r n minus 1 upon r minus 1. A is 10, r is 3 raised to power 5 minus 1 upon 3 minus 1, and you will get the answer. I hope this is just an application of the formulas. Now moving on to the next question. Difficult one. We have already covered this in the videos. If you can solve this, this is the type of question they will ask you in the exam, not the simple application base. So be prepared with all the previous year questions. You as many previous year questions you can do to be ready for the exam. This question we have already solved in our video. Today I am going to give you partial solution for this. You have to solve it on your own, right? So if you want a full solution, go to the arithmetic progression video. You will get the solution there. Now, if this such a series given to you, how will you calculate the sum of n terms of the series? First thing, is it a, uh, uh, arithmetic progression series? No. Why? Because difference between this is 40, difference between this is 400, difference between this is 4000, and so on. So this is not an arithmetic progression series. So we cannot use the arithmetic progression formula. Second part, is it a geometric progression series? Again, no. 4 multiplied by 11 is 44. But 44 multiplied by 11 is not 444. So it's not a geometric progression series. So now how will you solve it? The solution is take 4 common, 1 plus 11 plus 111, so on, and nth terms are there. Now multiply and divide by 9. 9, 99, 999, and till nth term. Now 4 by 9. How will you write 9? 10 minus 1. 99, 100 minus 1. 999, 1000 minus 1, and nth term. Now next step is 4 by 9. Take 10, 100, 1000 in separately. So 10 plus 10 square plus 10 cube and so on, nth term, minus 1 plus 1 plus 1 up to n times. So this is a geometric progression series, and this summation of this is simply 1 plus 1 plus 1, n times is simply n. So use the summation formula for the first part of sum of GP, and here the sum we already know, and then putting all these values, you will get the answer of n terms of this series. I hope this is clear. Now moving on. Again, this is a hard question, but try to solve such question on your own. Then only you can say I am ready for the exam. And how can you don't need to solve each and every question you find on your way. Just focus on previous year questions. They are your guide. They are your guiding light, right? They are going to help you, and they are going to keep you on the path where you want to go. You don't need to go here and there. Just focus on previous year question, solve them all, and you will be ready for the exam. And you just need to pass that 33% mark, and you don't need to be the topper in CSAT, right? Moving on. What geometric means? Again, I am going to make it fast. Same thing. 9 and 81, there are asked what is the geometric mean. So geometric mean, suppose I put in that geometric mean is G. Now, how will you get it? So to get G, I multiply 9 by common ratio, and to get 81, I multiply what? G by some common ratio. Means 9 multiplied by R is G, and G multiplied by R is 81. Now R is what? From first is G by 9. R from second is 81 by G. So G by 9 is equal to 81 by G. G square is equal to 81 into 9. G will be 9 into 3, 27. This is how you can calculate geometric mean. And what exactly geometric mean is? A number when placed between two numbers, the series of three numbers will become a geometric progression series. I hope this is clear. Moving on, and let's make it fast. There are two numbers, that is 3 and 48, right? I need to insert how many geometric means? G1, G2 and G3. Now this is the first term, this is the second, third, fourth and fifth. So fifth term of a geometric series, or AR, 5 minus 1, 4 is equal to 48. A is 3, R4 is 48. R4 is 48 by 3, that is 3 ones are 3, 16. So R is 2. When R is 2, so how do you get G1? G1 is equal to last number, that is 3 multiply common ratio, 3 to just 6. G3 is 6 into 12. G2 is 6 into 12 and G3 is 12 into 2, 24. And this is how you can calculate the geometric mean. I hope this is clear. I am making it fast. Why? Because this is very similar to arithmetic mean, which we have already completed. So don't worry there. Very basics. You just need to know what exactly the definition or the term means, right? Moving on. Harmonic progression. The last part. Again, we are going to understand this in the same way we have learned arithmetic progression and the same way we have learned geometric progression. Now, what exactly harmonic progression is? So suppose this is a harmonic progression series. H1, H2, H3, H4 and so on. Now they are going to tell you, is this is a harmonic progression series. How can you say this is a harmonic progression series? Now you do one thing. You take reciprocal of all the numbers. Reciprocal of all the numbers means 1 by H1, 1 by H2, 1 by H3, 1 by H4 and so on. So a series of all these number will be arithmetic progression series. I hope this is clear. Now let's see with an example. How we will see an example. Suppose reciprocal, suppose I am giving you this series 1 by 2, 1 by 5, 1 by 8, 1 by 11 and so on. I say this is a harmonic progression series. Is it yes or no? What are you going to do? You are going to make the reciprocal of each number. So reciprocal of this is 2, next number is 5, next number is 8, next number is 11. So you will check now. Is this an arithmetic progression series? Yes. So if this is an arithmetic progression series, this will be automatically a harmonic progression series. I hope this is clear. Moving on. What is the general term of an harmonic progression series? So harmonic progression simply, since we already know about the arithmetic progression, we are just going to reciprocal each term. So the first term of our arithmetic progression looks like 1 by, second term is 1 by a plus d, third term looks like this 1 plus a by 2d, fourth term is a 1 by a plus 3d and so on, and such series is known as a harmonic progression series. Nth term of a harmonic progression is 1 by a plus n minus 1 into d. I hope this is clear. Just the reciprocal of a arithmetic progression series. Moving on. Now, this is a mistake here. You have to find one harmonic mean between a and b. So how will you do? So if a and b are given to you, you have to place an harmonic mean between them such that this become a harmonic progression series. If this is harmonic progression series, now what can you say how it is a harmonic progression? You will do 1 by a, 1 by h and 1 by b. So what will it be? This will be arithmetic progression. Difference between these two is 1 by h minus 1 by a. Difference between these two is 1 by b minus 1 by h. So since these two are equal, so if you calculate this, you will get h is equal to 2ab by a plus b, and this is the formula to calculate a harmonic mean between two numbers. I hope this is clear. Basic, just one harmonic number between two numbers you need to know, right? I hope this is clear. Harmonic mean is also done. Now the last part, you just need to note these down somewhere. I don't know if they will be of any use, but still you need to know for the exam, because by chance some question could come like this. They might give you that arithmetic mean of two numbers is this, harmonic mean between those numbers is this. Now tell me what is geometric mean. So the formula for, or the relationship between geometric mean, arithmetic mean and harmonic mean is g square is equal to a into h or hm. I hope this is clear. And always remember, between any two number, or arithmetic mean will be always the largest, then lower, or the lower number will be geometric mean, and the lowest of three will be harmonic mean. So these two relations you just remember for the exam. They could be of use anywhere. Just note them down, and that's all. There is no direct question on this, but they can ask you in the exam. That could be a trick question, but if you know these two relations, such questions could also be solved. I hope this is clear. And that completes our today topic of progression. I know we have made it really fast, and that is whole purpose of this revision series. We want to keep the content crisp, but also at fast pace, so you don't need to invest a lot of time at this point of time. You focus on GS, do a lot of practice problem, and just watch one refresher video or one revision video each day, and that's all you need for the exam. Today what we have learned, we have learned what in progressions we learned three things, that is arithmetic progression series, geometric progression series, and harmonic progression. In arithmetic progression, what is arithmetic progression? What is how arithmetic progression series look like? What is the nth term? What is sum of first n terms? And also, what is the sum of first n natural number? In geometric progression, we have learned how a geometric progression series looks like. What is the nth term? What is the sum of n terms? What is the sum of infinite term? There is always a condition, don't forget that. And what is geometric mean? What is the more than one geometric mean between two numbers? Then in harmonic progression series, we learned what harmonic progression is. After that, what did we learn? How nth term of harmonic progression series look like, and also how to calculate harmonic mean between two numbers. And finally, we learned the relationship between arithmetic mean, harmonic mean, and geometric mean. And that completes our first video on the refresher series. We'll meet in the next video. Till then, best of luck for the exam. Focus now is the time. You invest 80% of your time on GS and 20% of time in CSET. In CSET, only focus on solving a lot of previous year questions, and just watch refresher video now to just get a reminder of all the formulas which you need to know for the exam. So see you in the next video. Best of luck till then.